So I can see people joining, quite a few joining in. I think we're expecting maybe around 70 people.
Yes, just wait, let's wait for a few minutes and let's see how at least some of the people can join us, and then we can start.
I think we're up to 23 at the moment. Still more people coming in.
Okay, we have 28. So the moment it hits 30, maybe we can start on 30.
Yeah. Here we are.
Perfect. So hello, everyone. Good morning. Good day to you. Welcome to this webinar. Today we are having a technical webinar on how wastewater can be used in buildings for addressing the heating and cooling energy requirements. I have with me expert speakers today. Can we go to the next slide, please? Mr. Nick Meeten, he's the Director of Applied Energy, and also Mr. Julen Imaña Sobrino, who is working with ICLEI European Secretariat with the Sustainable Resources, Climate and Resilience team. My name is Rohit, and I'm the Head of Sustainable Energy at ICLEI World Secretariat. I will be moderating the webinar for today. But before that, I want to just set the scene a bit and see where we are today with respect to the energy transition. We see for cities that already accounts for 78% of the global energy consumption and also 55% of the world population. And we account for more than 60% of the GHG emission. This being said, we are almost 1 billion people, mostly from Africa and South Asia, who lack access to basic, modern, affordable, and reliable energy. And this is something we need to keep in mind while moving into the future with the energy transition. How is this transition going to look like? What are the basic technologies? What are the basic applications that are needed here? Sustainable energy use in the present can help guarantee such use for the future generations as well. Next slide, please. So at ICLEI, we have already positioned ourselves with what we recognize as sustainable energy sources, which are being used for the sustainable energy transition that we see, which is using hydro, bioenergy, wind, solar power, and so on. Also looking at the sustainable transitional enablers, which is green hydrogen, smart grid storage, and so on. But making sure that the energy transition itself is context specific, socially sensitive, and nature conscious, which addresses the need for electrical as well as thermal power, thermal energy consumption for the various sectors that we have, whether it is industry, power generation, buildings, and so on. Next slide, please. We already have seen the sustainable energy is the cornerstone for most of the initiative and activities that is going around for climate change, the climate crisis, whether it is Race to Zero, whether it is talking about the SDGs, whether it is the green recovery, we mentioned net zero emissions, and so on. It is the most important thing for decarbonizing various sectors. most of the climate solutions, climate problems have energy in them. So sustainable energy solutions need to be at the heart of the climate solutions. We can also see with renewable energy, further climate adaptation and resilient efforts can be made. Moreover, it is bringing in energy security and independence at national and local levels. And not to mention that transitioning towards a sustainable energy system will overall achieve the climate neutrality and net zero emissions that everybody is looking at to achieve by 2050. Next slide, please. At ICLEI, we are looking at how to achieve this through our climate neutrality framework, which is embedded in the Green Climate Cities program, where we see as the entry point to be the resilience development, then addressing the climate adaptation, resilience, and mitigation through a stepwise customized guide for all cities and regions, which looks into the main 3 steps of analyze, act, and accelerate, which opens up further into 9 steps of how these can be implemented, planned, and further accelerated. The climate neutrality framework further depends on 3 pillars that we have, which is first looking at how drastically greenhouse gases can be reduced, how further divestment and repurpose and reinvestment can happen, and third, offset and compensation of greenhouse gases. Can we go to the next slide, please? From our perspective, local action is critical. Why? Because we understand that the local governments, the local authorities, municipalities are uniquely positioned where they can understand what is needed on the ground with the local citizens, the population, what is the need, and can understand the pulse. And of course, then they are at the best position to also look at local targets, whether it is looking at public transit, looking at building heat and cooling requirements, energy efficiency codes, etc. And they can also support various other actors, including the national government as well as other stakeholders, looking at how the local regions can attain clean energy resilience, whether it is enhanced climate action, creating local economy, and of course, helping the national international corporations. With this, can we go to the next slide? With this, we today want to look at, to achieve these goals of net zero emissions and the sustainable energy transition, how one of the major energy needs of heating and cooling can be attained through wastewater, which is something that needs more attention, because we have seen building energy accounts for 1/3 of the final energy demand globally, of which 77% of this demand is thermal energy needs. As of now, renewable electricity supplies only 9% of the heating in buildings, and cooling demand is growing 4% annually. So looking at this, the policy support we need, the urgent action that is needed, I would like to hear from our experts today, what is that we can do, and what is the solutions and applications that they would propose from their experience, expertise, and the projects that they are working for. Next slide, please. And with that, I would first hand it over to Mr. Nick Meeten, who would then tell us about the wonderful work that he is doing with his various projects. Nick, the floor is yours.
Thank you. I'll just share my screen. All right, wrong screen. Hopefully you can see my screen. Yeah.
Yeah.
Okay.
Yes.
Thank you. Look, we've got people on the event today from all around the world. So depending on where you're sitting, I'll say good morning, afternoon, or evening. And thank everybody for giving up their time. And so the focus for the event today is on Europe. I think we can all agree that environmentally, the planet's in a pretty bad state, and I think we all know we need to change quite quickly. We're actually really seeing the impacts of climate change faster than even the scientists were predicting, and personally, I find it quite scary. On top of this, Europe has got this massive energy challenge caused by Russia's invasion of the Ukraine. And so energy is now becoming really a national security issue. I think the time for talking is over. We actually need to be starting to actually get on with stuff. And time is really one of the critical factors. I've made a personal promise to my kids that I'm going to do everything I can to protect their future. And so using my knowledge and my passion for this topic, I think is how I can make the biggest impact on their behalf. So with that said, we won't waste any more time and we'll get on with it. Let me introduce myself. I'm a mechanical engineer and I've spent over 25 years designing the heating and cooling services for commercial buildings, over 14 years working with water and wastewater, and then bringing these different sectors together under the common umbrella of sustainability. I've lived and worked in different parts of the world, including many years in Europe. And I've been involved in over 80 wastewater heat recycling projects all over the world. Now, I'm a director of Applied Energy. We're a small company and we enjoy specializing in this kind of unusual niche of wastewater heat recycling. And we're actually very passionate about it. On the right side of the slide there, you can see some of the high level work that I've been invited to do on this topic, such as writing a piece for the United Nations District Energy and Cities report, specifically on this topic of using wastewater as a thermal source for district energy networks. I got invited to contribute to a smart cities report for the UK government. And in the US, the Water Environment Federation wrote a report on the state of the science and issues related to heat recovery from wastewater. So I got asked to contribute to those things. So it's an unusual topic, and there's not that many people sort of working in this weird little niche. So the plan for today, at least in my presentation here, we're focusing on planning, and like I say, it's focused on Europe, but I know that there are people in the audience from around the world, so there will be examples from outside of Europe as well. We're not going to get into the technical side of things too much, so we're not going to be talking about pumps and heat exchangers and heat pumps and those sorts of things. We're really focusing on the planning aspects. I'll deliberately try and keep technical stuff very simple, but if I do say something that you don't understand, I would say please don't be shy and ask for clarification in the Q&A box, because if I've said something that you don't understand, then the chances are there's other people in the audience who probably have got the same question. I'll talk for about 40 minutes or so, and then Julen comes after me. He's talking about district energy, and we'll have time at the end for questions. So I would really encourage people to ask questions, because often that's when the really good stuff, the learning comes out. So we'll start off talking about policies, and this is a very fast changing space globally. In Europe, there is new policies being announced at pretty regular intervals, and sometimes it's quite difficult to keep up. The main trend that I see in policies is banning of fossil fuel boilers. And the question then becomes, if you can't heat with gas or oil boilers, then where are you going to get the heat from? Other trends which are around increasing the share of renewable electricity within the electrical grids, and also moving to electrification of heat, typically via heat pumps. There's also a policy trend to electrification of other sectors. A very obvious one is transportation, moving towards electric cars and vans and trucks and buses, and etc. And of course, with all this electrification going on, there's more competition for electricity, so that's becoming quite an issue. The last policy I'll mention, which is specific to Germany, is they've announced 3 billion euros for renewable energy and waste heat-based district heating. So they are really encouraging, I think, networks to run on 75% renewable energy or waste heat, or for projects decarbonising existing networks. So that's some of the policy stuff that I've noticed from Europe. Now, if we look at the balance between thermal energy and electrical energy. So this is global from the REN 21 data. But what we can see there is that the demand for thermal energy, which is heating and cooling, is actually 3 times greater than the demand for electrical energy. So we're talking about the 51% versus the 17%. And as Rohit mentioned, the thermal energy often doesn't get enough attention compared to electricity. And so I often see in the social media that people are talking about heating and cooling as being the energy elephant in the room. It's really the big one, but it's not getting talked about that much. If we move to start off and look at the residential sector within Europe and look at the energy flows within typically our houses. So in Europe, over the EU 27 countries, about 15% of the total energy that's used in houses gets turned into heat in your water heaters. And this is the second largest use of energy in houses after space heating. All this heat energy then flows down into the sewers as the hot water gets used. And hopefully, I'm sure you'll agree that 15% is a lot of energy that's heading down the drain. I would also say that this is probably on the low side because there are other sources of hot water that we all have in our houses, such as things from cooking. If you cook pasta or you boil pasta or vegetables or so on, and then you drain it, that's hot water goes down the drain, but it's not coming from your water heater. Likewise, dishwashers and clothes washing machines, they often heat the water within the appliance, not using hot water. So all of those heat or hot water sources also go down the drain. So 15% is probably on the low side. And the thing is that this heat, like the heat from space heating gets lost to the atmosphere as it leaks out through the walls and windows and roof and so on. But the heat from hot water is not lost to the atmosphere. It's contained in pipes nicely for us. If we stand back and look from a wider perspective at a typical city, and we add in commercial and industrial low temperature heat on top of the residential sectors, the amount of all of this heat that ends up in the wastewater network actually increases somewhere in the order of 30 to 40%. So in every city, what we've got is a wastewater network, which is a large collection system of free heat from thousands or tens of thousands, or in bigger cities, hundreds of thousands of houses and apartments, as well as all the commercial and industrial buildings. Now, of course, this hot water gets mixed with cold water as we use it. We know that. So what we end up with in the wastewater network is a much larger flow of slightly warm water. And this water flow contains an enormous amount of thermal capacity for heating and cooling, okay? But unfortunately, currently all of this energy is just wasted and it gets flushed away. Now, I just want you to absorb this image for a moment. This is showing across Europe, there's 18,000 wastewater treatment plants. And the size of each of those symbols relates to how much heat would be available at each one of those plants. So every single wastewater treatment plant is potentially a source of thermal energy. And what's not shown on a map at this scale is that every single one of those wastewater treatment plants is connected by a pipe network, the sewer network, right up back into the city to each of the houses and buildings. So there's a massive amount of heat that's available at all of these spots for use. And at the moment, we use basically nothing. So this next map is a filtered version of the one that I just showed you, because what this shows, bearing in mind that we're talking about how critical time is, this is showing the really easy ones that could be implemented very quickly. So this map filters out most of the plants and it shows only those that are already inside or within 2 kilometers of district heating networks. And so there's still about 4,000 wastewater treatment plants that fit this criteria across Europe. The total heat energy that's available from just these 4,000 is around 625 petajoules, and that's the energy equivalent of burning 100 million barrels of oil. So this map's showing 4,000 examples of easy, quick energy gains that are available in Europe. The heat collection and the heat distribution infrastructure on both sides, and so I'm talking here about the wastewater pipe network and the district heating pipe networks, are already built, or at least planned, but most of them are already built. And these pipe networks just need to be linked together with some appropriate heat exchangers and heat pumps, and bingo, suddenly they are recycling wastewater heat, which is currently being thrown away, and supplying it as electrified heat to large numbers of residences via the district heating network. And so that is allowing many thousands of houses to be heated without gas. And these are pretty big numbers. And remember, the ones that are shown here are only the really easy ones, the treatment plants that are already near district heating areas. If we pro rata this up from 4,000 plants shown here to the 18,000 total wastewater treatment plants in Europe, the heat energy is up around 500 million barrels of oil equivalent each year. And this heat energy it's available right now. It's within infrastructure that's already constructed, but it's just being flushed away. And these are enormous amounts of energy. The trouble is it's kind of right in front of our eyes, ready to be recycled, but we just don't see it. So at the moment, we've got all this fantastic heating and or cooling being flushed away every day in every town and city, but it doesn't need to be. So the idea that we're discussing today is just don't waste it. Capture the heat and recycle it while it's still in the city where it's needed. This thermal energy can be used instead of fossil fuels to heat buildings or industrial processes or for district heating. And so it brings down the carbon emissions. It's also actually using the wastewater infrastructure for a second and actually a higher value purpose than just moving wastewater out of town. It's using the wastewater network as an energy source. And as the price of other energy sources climbs, and that's happening in Europe and quite dramatically at the moment, the value of the energy that's flowing through these wastewater pipes rapidly becomes more valuable as an alternative. Energy can be sold, we all know that. So energy recycling, it also fits with the concept of a circular economy, which is kind of rapidly becoming adopted as the way forward to become sustainable. And sometimes these things, they're overlooked because they're right in front of our eyes. I keep saying that, and that's the case, I think, with wastewater heat. It's right there beneath our feet every day, right where it's needed. We just don't see it. We ignore it and throw it away. So we'll start talking about some of the characteristics of the topic. And I'll start off assuming that some of you haven't had the pleasure of seeing what flows through wastewater pipes. Wastewater is basically just dirty water. The United Nations officially states that wastewater is 99.9% water. The point is that it's water, and the thermal properties of this fluid are unchanged from clean water. So its ability to absorb heat or to move heat, to give up heat, are all still the same as clean water. And we know that water is a very good conductor of thermal energy, much better than air, for example. So I would encourage you, when we're thinking about this topic and you're thinking about wastewater, try not to get grossed out. In the wastewater, we talk about the yuck factor. Forget it, okay? Get over that. Just think it's water, and the heat is clean heat. So don't worry about the fact that it's wastewater. It's just water, and there's an enormous amount of clean heat energy there. Another characteristic which is important when we're trying to make plans is timing of the capacity. So almost every city follows a relatively similar pattern of wastewater flows. And on this chart here, you can see three different 24-hour flow patterns for wastewater networks. They're all slightly different, but they all follow a very similar trend, which is relatively low volumes during the times of day when we're all sleeping. And then starting from around 6 a.m., they ramp up rapidly. You get a peak in the sort of the late morning, then it drops off a wee bit and you get another peak in the evening. But what we can see is that the times of the day when buildings are occupied and buildings are needing to be heated or cooled matches up very, very well with times of the day when there are high flows in the wastewater networks. So I like to describe this as saying that wastewater networks and buildings, they breathe in and out in the same rhythm. And that's good for planning because the supply and the demand profiles match up. Good stuff, huh? Now let's talk about temperatures. Another aspect when we're doing planning. So this chart shows 20 different temperature data sets for wastewater flows in cities through Europe, the US and New Zealand over all 4 seasons, okay? What we can see is that wastewater temperatures are very stable, relatively neutral. They typically vary within a band of about 8 degrees Celsius over the 4 seasons. And they are typically averaging around 14 to 18 degrees Celsius over the whole year. Now, that may not sound terribly warm to some people, but when you think that heat pumps can extract heat from air, which is minus 10 degrees Celsius, water, which is 14 to 18, is actually pretty warm. So these sorts of temperature ranges are perfect as a thermal source for heat pumps. They work really well. I know right now Europe is just coming out of an extreme summer. And so hot weather is also just as much of an issue in Europe as cold weather will be in the coming winter. Hot weather is driving the growth and demand of air conditioning, which typically results in heat being pumped out of buildings and discharged into the air, either via wet cooling towers or dry air-cooled condensers. So in cities, discharging all of this heat into the atmosphere increases the issue, which is called the urban heat island, where the middle of the city is quite a bit warmer than the outskirts. And so you end up with this heat bubble in the city, which then drives the demand for even more air conditioning. And so we have this growing cycle of more. And wet cooling towers, I would just add, consume quite a lot of water, which in times of drought, which is, I know, another issue Europe's having right now, this water could be used for other purposes. Another thing when we're talking about cooling is all of these cooling methods, I'm talking wet cooling towers or condensers, they all use fans to move the air. Fans are noisy, right? So when we start getting more and more fan-powered coolers being installed, the noise pollution also grows rapidly. Now this slide shows modeling of the impact of air conditioning on the urban heat island profile in Paris. The modeling was done about 10 years ago. And at that time, the thought of twice as much air conditioning being installed as was predicted at the time probably seemed a bit like a fantasy. But I'm sure at the moment, given the heat waves and things that Europe has had recently, it actually seems pretty probable now. So now wastewater offers an alternative place to pump some of the heat instead of pumping it into the air. What are the benefits? You get water savings from not using wet cooling towers. You can get a quieter city and you can get reductions in the urban heat island impacts, and you can get energy savings. So talking now about temperatures again, this is a comparison between wastewater temperatures and air temperatures. This data is from the city of Christchurch in New Zealand, and Christchurch has a climate which is statistically 97% the same as Paris, 96% the same as Brussels. So not very dissimilar. And the principles that I'll show you here apply to most cities within temperate parts or temperate climate zones. So firstly, you can see how stable the wastewater temperatures are. That's the red line. And that in winter, wastewater is much warmer than air. Equally, In summer, wastewater is cooler than air. And this predictability and stability around temperatures and flows that I've shown over the last few slides are fantastic qualities for planning. And so they make wastewater really an excellent thermal source for heat pumps, for both heating and cooling. That's why I wanted to show this slide, heating and cooling. It allows heat pumps to operate at very high efficiencies, which means you can heat and or cool a building without burning fossil fuels and using less electricity than air source heat pumps. And that's the win, okay? That's the nub of why we're here. Electrification of heating with very high efficiency with electricity. So I just wanted to show a case study from the US around electrification of heating. So this building is in Atlanta, in Georgia. It's the office building of ASHRAE, which is the American Society of Heating, Refrigeration and Air Conditioning Engineers. So for heating and cooling guys like me, this is kind of the headquarters of Geekland. It's a pretty standard 2-level office building, you can see that. And some years ago, they decided to refurbish it. And as part of this refurb project, they wanted to use their own office as a living lab. And so they installed an air source heat pump system on one level and a groundwater source heat pump system on the other level. They installed lots of data loggers, lots of sensors, electrical meters, etc., to monitor everything that was happening. And they operated it for 2 years, gathered together all of this data and analyzed it. And what they found is that the ground source heat pump system used half of the electricity as the air-based system. So if you're using half of the electricity to do the same thermal job, that makes it twice as efficient. So that's the sort of efficiency gains we're talking about. Now, admittedly, this one was using groundwater instead of wastewater, but groundwater and wastewater are both very stable in temperature over the whole year. And we know that ambient air is always heading in the opposite direction to what your heating and cooling needs are. So by that, I mean in winter, when you need heating the most, the ambient air is the coldest. But that's with an air-based system, that's exactly where you're trying to drag heat out of. And likewise in summer, when you need cooling the most, the ambient air is the warmest. And with an air-based system, this is exactly where you're trying to push heat into. So you're always fighting against nature. And with a stable and relatively neutral thermal source like wastewater or groundwater, you're not fighting nature so much. And so you don't have to work as hard. And so the efficiency is higher. And this is why you need less electricity to do the same thermal job. Now, while this ASHRAE study is not comparing air source with wastewater source, since wastewater has very similar temperature profiles to groundwater, except that it's warmer due to the hot water energy included, compared to a groundwater source system, wastewater will get better efficiencies in heating mode, but slightly worse efficiencies in cooling mode. But overall, both wastewater and groundwater are much better thermal sources than air source. And wastewater is already in the pipes. And one of the things about when we're talking about water sources, you don't need to worry about contaminating wastewater because, as we know, it's already dirty. Now I want to focus specifically on a specific type of building, which is swimming pool centres. Why? Because these types of facilities are huge consumers of low-grade heat. Even in summer, they need heat. And for many cities, swimming pool centres are one of their biggest energy costs. And excuse me, here is some benchmarking we've done, which compares aquatic centres in Australia, New Zealand, and the UK. And so these are the green bars on the left against other types of commercial buildings like offices, retail malls, and education buildings. They are the blue bars on the right. On average, the aquatic centres use 5 times more energy per square metre than the average of the other types of commercial buildings. There is one bar on this chart, which is orange. This is an aquatic centre in Australia, which uses wastewater heat. And you can see that it is about 60% below the average of the other aquatic centres. Excuse me, I just need a drink. Now, hopefully you'll agree that's pretty impressive. I'm not saying we can take this one single example as guaranteeing that sort of performance for all of them. We do have other performance reports from aquatic centres in France, which use wastewater heat, and they tell us that the average coefficient of performance of their heat pumps over 12 months is, in the range of 5 to 7. So it is pretty impressive. But my point is that because aquatic centres use predominantly low-grade heat, and that's kind of heat in the range of 30 to 70 degrees Celsius, where it's feasible, aquatic centres or swimming pool centres make a perfect match for wastewater heat recyclings. Now, I just want to say, so typically public institutions like city authorities often don't want to be the first ones to try something because it might be risky. So the first wastewater heat recycling systems were installed in Europe. Actually, they started in Switzerland about 30 years ago. And my estimate is that there's probably about 1,000 systems in operation around the world. So these technologies are now starting to become pretty mature. The adoption of them is starting to spread, but from our experience, it's generally poorly planned. That's why we're talking about planning today. It's often done, it might be a building here and a building there, but no real plan. And so the best value for money is not being realized. So what I want to do now is have a very quick look at a few examples of wastewater heat recycling installations, which I've chosen to span a range of building types, just to give you a feel for where these systems are used. I haven't picked all the fancy ones or the most impressive ones. Some of them are really quite ordinary buildings. And I will run through these quite quickly. I'm not going to dwell on them too long. It's just to give you a feel for some of the applications that are in use. So here's one in Stuttgart in Germany. It's a government office building using wastewater heat recycling. You can actually see hanging off the crane there, that's one of the heat exchangers that was being lifted over while they were being installed. And on the images on the right side, you can see the heat exchangers when they are installed. So, these are clean installations. There's no risk of sewage running all over your floors. We're not pumping sewage through any buildings. It's not dirty and smelly. So there's nothing to be afraid of. Here's a pretty typical office building in Switzerland. It's 28 levels high. It's been heated and cooled from wastewater. It's been in operation since 2011. And just to give you a feel for the thermal loads, it's providing 480 kilowatts in heating mode and 840 kilowatts in cooling mode. This swimming pool centre in Australia is the yellow bar that I showed you on the benchmarking chart. So it's in Hobart. It's been in operation, the wastewater heat recycling system, for about 20 years. And interestingly, Hobart is a little hotpot of technology there, this particular technology, because there are 3 other buildings in Hobart which are also using wastewater heat recycling. That's their own municipality office building, a hotel and a retirement home. Here's a selection of swimming pool centres that are all using wastewater heat recycling. 3 of them are in France, so 2 in Paris, 1 in Marseille. Here's one from Vancouver in Canada. It's called the Southeast Falls Creek project. This has been in operation since 2010. It's a district heating network with wastewater providing about 80% of the heating. And what they've done is tapped into a large sewer, which runs across the bridge in the top left corner of the picture there. The red buildings show customers that are currently connected to the district heating network, and there's about 3.2 megawatts capacity in that network at the moment. The blue buildings indicate future customers who will connect once a 6.6 megawatt thermal expansion project is complete. This is in the town of Straubing in Germany. 5 pretty ordinary little apartment buildings, which are providing 102 municipality supplied apartments for elderly people. They're all being heated with wastewater heat. It's been running since 2010. Now, this is an interesting one for me. It's from the UK, and there are 2 sites here where commercial glass houses have been deliberately constructed close to the wastewater treatment plants so they can recycle the heat from the wastewater via heat pumps for low carbon heating of the glass houses. And I find this interesting because often the land around wastewater treatment plants is very lowly valued, often because there might be a bit of odor associated with it. But in the future, I think this might start to change when people see uses like this and the thermal energy that's available at wastewater treatment plants. Hospitals are an excellent match for wastewater heat recycling because they also need a lot of low-grade heat pretty much all year round. This one is in Budapest in Hungary. Here's one from Washington, DC in the States. It's the headquarters for DC Water. This has been in operation since 2018. It's LEED Platinum. And when they were designing this building, they looked at 3 different ways to provide the heating and cooling. One was a conventional air-based system. One was wastewater heat recycling, and the other one was geothermal. They estimated the costs at $700,000 for the conventional system, $840,000 for wastewater heat recycling, $1.4 million for geothermal. And when they factored in the efficiency gains, they said it was an absolute no-brainer to go for the wastewater heat recycling system. This one's also from Budapest. It's a mixed-use facility comprising retail, hospitality, performing arts, and their municipal council offices using wastewater heat recycling. One from Japan. I don't know much about this at all. It's been in operation since 1994, and it's a 21-hectare area servicing office buildings, hotels, and commercial facilities via a district heating network. Another one from the States. This is in Denver. It's currently in the construction phase, and the wastewater heat recycling system will supply a district heating cooling network for the whole campus of buildings that you can see there. The wastewater heat recycling energy centre is actually finished. It was completed in April, became operational. It's got a 4 megawatt thermal capacity. Another hospital in Toronto, construction of that one has just started last month. When it's completed, it's going to be one of the biggest ones in the world with a 17 megawatt thermal capacity. Here's one here in New Zealand. It's our first one in construction right now. It's due to be operational in about 6 months. It's a large aquatic centre with a 3.5 megawatt thermal capacity. Just to give you a feel for sometimes when things are not located directly beside each other, here's an aquatic centre in France. The wastewater pipe is 350 metres away from the building, but that's no problem. They've got the wastewater heat recycling centre there where the blue box is, and run some pipes over to the building. And a similar one in Canada, where they've got the Panorama Recreation Centre there on the left side. The wastewater treatment plant is 700 metres away. They've put heat exchangers at the treatment plant. They've got a closed water loop over to the building with heat pumps there. And they've designed that system to allow for future expansion upwards to the school, just to the north there, and just to the south of the aquatic centre to like an industrial site there. So that will, I guess, eventually have a little precinct scale district energy system. In Scotland, there's a whole business park here that was use wastewater for heating and cooling. And this is my last example. It's a project in the Netherlands, and they are tapping wastewater heat from the treatment plant there, using heat pumps to supply water at 75 degrees into an existing district energy, district heating system for 20,000 houses. And this is an exact example of one of those 4,000 quick, easy possibilities in Europe that I showed in the earlier slide. You connect the wastewater treatment plant with a district heating network via heat pumps, and suddenly the heating, in this case for 20,000 houses, has been electrified efficiently, and they can stop burning gas. I want to also add that district heating networks can also be supplied with wastewater heat from within the wastewater network. It's not always necessary to go to the end of the network at the wastewater treatment plant, but to allow these sorts of things to be planned, the information is needed. So that's where I want to really start talking about the planning part of it, because that's the focus of today. So as I mentioned earlier, our experience is that wastewater heat recycling is generally done in an unplanned way, rather than a city having a plan on how to use this resource. So if we want to start talking about where do we start? If a city is interested, where do they start? The first step is to actually make this thermal energy visible, because when it's running through the pipes, it's just invisible. Once it's visible, then planners can start to include it in their plans. And we should remember that this heating and cooling source is running right through the city. It's exactly where it's needed. So visualization is done by heat mapping the wastewater network of the city. So the snips that you can see on the slide here are from 2 of the cities that we've done wastewater network heat mapping for. Once the mapping's done, then ideally, the information is made freely available to anyone. And when I say freely available, and this is my personal view, that means something like online. It's not guarded by some city official, because we should remember that the people of the city are donating this energy into the wastewater network every day for free. And I believe that city authorities actually have a moral obligation to their community to make this resource visible. However, I also know that in Europe, data security is a very sensitive topic. And so many city authorities may not be comfortable to have this information so easily accessible. So there are different options available to match the comfort level of the authority concerned. These could include, for example, having the data on an online map, but access is controlled via a login. Or maybe the data outputs from heat mapping could be provided to the authority, so it's only available on their mapping system. Again, maybe they can make it maybe public, or maybe they will keep it in-house. Or maybe the heat maps are only available as hard copy maps, or maybe the city simply tell the people that the data has been prepared and it may be available upon request. So the data access can be controlled to suit the requirements of the authority, but the first step to allow it to be considered for planning is to get the data prepared. The US report that I talked about, the Water Research Foundation, they state in their report that the mapping process is an essential tool for policymakers. They say it allows the governing community and the developer community to conceptualize the resource available and then how to connect them to needs. So I would also add, for anyone in the audience who's involved in energy or infrastructure planning in developing regions of the world where wastewater networks are maybe not yet fully constructed, but they are being planned, this is the perfect opportunity to integrate heating or cooling planning into the wastewater network. It's significantly cheaper to build access for heating and cooling into the wastewater network right from the start than it is to retrofit it later once the pipes are in the ground. So this is the starting point for planning. And this heat mapping services, of course, it's a service we can offer. We've done full wastewater network heat mapping studies for 4 cities, and we've done 7 partial heat mapping projects in other cities. So we've got this expertise and the processes and the technology well established now, and this is available to assist any other cities that want it. Here's an overview of our process. It's a 3-stage process as set out here. Stage 1 takes about 10% of the work. Stage 2 takes about 50% of the work, and stage 3 takes the remaining 40% of the work. So as I mentioned, we've learned how to do this by doing it a number of times now. So we can do it quite efficiently for cities, not only in Europe, but in other parts of the world. Here's an example of the deliverables from one of the heat mapping jobs. Christchurch is a city of about 450,000 people. So the study was documented in a written report, which describes all the processes. That's important so that everybody understands how we come up with the heat maps, which are based on data. Where does that data come from? So we have to document the criteria that's been used, the assumptions that are made, the risk assessments that are made, the thresholds that are established, because wastewater networks are not an inexhaustible source of energy. They've got a huge capacity, but there are limits. So we have to establish what those limits are. And the deliverables, apart from all the written stuff there was also a full map atlas of 25 maps that covered the whole city. As part of our process when we're doing these studies, we can take into account things like where there's urban growth planned, where there might be commercial or industrial developments planned. We have to look at what treatment processes are used at the wastewater treatment plant, and establish therefore what thresholds there are for taking heat out of or adding heat into the network. But also when we're doing these sorts of things, as we identify where there are likely to be very good opportunities for wastewater heat recycling. And in Christchurch, we identified 11 potential sites, which would be really highly feasible. Since we did this report, other sites have also come along, but this type of integration into the planning can only happen once the information is available for people to use. Here's some examples from 2 other cities where we've done the heat mapping services, Nelson and Dunedin. Again, now that they've got this information available, it's been incorporated into planning for things like heating and cooling energy options for swimming pools, for airport hangars, for buildings, schools, university campuses, and commercial offices. Again, it's only because they've got the information available that they can integrate it into their planning. So if you make this invisible energy visible, wonderful things can happen. So I said before, Applied Energy, we're a small company, but we are part of a global network called the Heat Academy, which is actually headed out of Sweden by Mr. Peter Underberg, who is hopefully watching this event today. So hello, Peter. And this network that we're part of, we've got people in 28 locations around the world, most of whom are actually in Europe. So we're here and we want to help. How are we going for time? I think I'll leave it there. So that brings me to the end of the presentation. I hope you enjoyed it. And now we'll go to Julen, who will be talking about district energy. But if you've got any questions, guys, can you please put them into the Q&A box?
Thanks a lot, Nick. That's really impressive stuff. We're already getting some questions. I would also request everyone, please, if you have questions, remarks, comments, please put it in the Q&A box. That will help us to focus more on our discussions later. Without further any ado, Julen, floor is yours.
Thank you, Rohit. Thank you, Nick, for the very interesting presentation. I see that wastewater heat is really promising for the whole world and, of course, for Europe. And now I would like to give you a bit of the European perspective. Let me know if you see my slides right now.
Yeah, we see it.
Okay, great. Then, sorry. I will move directly to why is district heating and cooling planning so important currently in Europe? Well, first of all, as you already mentioned in your presentations before, the increasing energy prices are an issue that we have been tackling within the last couple of years. Prices are rising a lot, and this is not expected to go down any soon. We also have to find a sustainable alternative to the Russian gas after the war that we are having in Ukraine because of the Russian invasion. And additionally, if we look at some numbers of 2019, the people unable to keep their homes adequately warm in the EU was about 7%, and these numbers are only getting worse with the current situation. Therefore, I would say that this is the perfect time for taking action right now into thermal energy planning because of the high awareness of citizens on the one hand, because of the energy prices, also the sense of urgency and solidarity we have right now with the situation that we are living. So rapid action is definitely needed in Europe. Additionally, these numbers are very similar to the figures worldwide that Nick shared just a moment ago. We can see that in Europe, heating and cooling accounts for half of the total energy needs, and 75% of it still depends on fossil fuels. Therefore, we obviously need a very rapid change at a local level with very innovative solutions so that we can reach all the climate goals that the European Union has set for 2050. And I wanted to show you a bit what are these climate goals, which is the current picture of the policies in place in Europe right now. We have, first of all, the Glasgow Climate Pact. This is a pact that was adopted by nations in the COP26 in Glasgow. They wanted the 2020s to be a decade of climate action and change in the nations, committing to phase out coal and reduce the fossil fuel usage. And we can also see that we have the EU Green Deal in place right now. It's the plan that the European Union has to become the first carbon-free, carbon-neutral continent by 2050. We also have the Fit for 55 package, which is a legislative package that wants to reduce net greenhouse gas emissions in Europe by 55%, sorry, by 2030. And the interesting thing of this package is that they propose that all regional and local authorities should have heating and cooling plans if they have a population of about 50,000 inhabitants. If we also, you might also know what the Covenant of Mayors is. This is a movement of for local climate and energy actions across Europe. They help the local authorities to develop sustainable energy and climate action plans, also local green deals. So as you can see, there's a lot going on right now. Therefore, we have to really focus into heating and cooling planning so that we can achieve all these objectives and so that we can keep opportunities flexible, keep the prices low, which is very important, and have access to different heat sources, renewables if possible. For example, this wastewater heat could be a really good solution for some of the cities in Europe. And district heating and cooling is key for achieving this flexibility because it allows more efficient systems and the incorporation of renewable technologies, as you might know. Now, before moving to some specific projects we are working with in ICLEI, I wanted to show a couple of cities that are leading the way to decarbonize the heating and cooling sector. First of all, we have the city of Helsinki in Finland. As you can see, they want to be carbon neutral by 2035. So they created estimated the scenario for this year for the business as usual scenario. So in this scenario, the heat consumption would increase by 7%. And then we would have a bit of more geothermal heating and district heating in the city. And the coal plant actually in place in the city would be closed by 2024. If we look at the more ambitious carbon neutrality scenario, they expect to actually reduce and not increase the heat consumption, reduce it by 19%, to increase a lot of the geothermal heating. And what is very interesting is that they want the 70% of the district heating to be emission-free in the city. if we see another city in Europe, like Mannheim in Germany, this city wants to be carbon neutral by 2030, so even earlier. And in their climate action plan, they have several goals. First of all, is to also decarbonize their district heating system. They are currently having this system supplied in a 60% with hard coal from a nearby power plant. And they want by 2030 to replace this heat supply by river heat, geothermal, and biomass sources. So as you can see, cities are doing very interesting work, trying to find innovative and alternative heat sources. And of course, wastewater heat could be a very good option for many of these cities. And now, in this slide, you can see as four projects that are related to the topic of heating and cooling. We have, first of all, Acton Heat, a project that we are currently working on in ICLEI Europe. And as is the only one of these four that is currently ongoing, I will talk about it more deeply in a moment. But I also wanted to mention Heat Roadmap Europe, a former project which we worked on. The focus of this project was on waste heat for district heating, and they developed several roadmaps giving tips for the decarbonization of the heating and cooling sector. Very useful. You can go check it in their website. We also have the Thermos tool, which is well, it is a project which developed the tool with the same name, Thermos, a free web-based software that can be used for energy planning. This tool can help us in designing district heating or cooling networks in our city in a very user-friendly way. It can create different network solutions instantly, and I will also explain it a bit further later. And then we also have the Keep Warm project. This was a project that wanted to accelerate the cost-effective investment in the modernization of district heating systems. They developed some recommendations for national and local authorities on how to retrofit district heating, and a guidance booklet also on how to improve district heating networks. So I also encourage you to go check it in their website. But as I said, I will focus on the Acton Heat project, as is the one that we started working on last year and is the one that is currently ongoing. This is an EU-funded project, and ICLEI Europe is one of the partners in this project. So, what is Acton Heat? First of all, Acton Heat is a project that is looking to accelerate the local heating and cooling transition. And we are doing that by, first of all, identifying different success factors of effective energy plans in different cities across Europe. And with these success factors, we created a workflow on decarbonizing heating and cooling that I will explain you in the next slides. We are also developing different support activities, both individual and group support activities, to guide municipalities or relevant stakeholders in applying the workflow. These support activities can be either online trainings, as we already did a round of online trainings last year, and we will have a new round of trainings in the beginning of next year. So if you are interested, you can stay tuned in our website. And we are also rolling out a support facility for municipalities that I will explain in the next slide. And finally, we are also facilitating the finance and the design of effective heating and cooling projects in Europe. So as I told you, we are rolling out a support facility in Acton Heat. This support facility aims to support 120 municipalities during the project lifetime. We already started with the first round this year, and we want to help municipalities to start, continue, or improve their heating and cooling plans. We also want to focus in 30 pre-feasibility studies for some of these individual projects. And also 15 of the projects can benefit from additional performance and financial analysis. So we encourage all the municipalities across Europe to apply for this opportunity. The call for applications will be open in the end of September of this month. So you can stay tuned or go to the website and fill in the expression of interest, and then we will contact you whenever the call opens again. But now moving to the workflow for the heating and cooling planning. This is the workflow we came up with for that is addressed to energy agencies, consultants, and local authorities. We see that every planning will start with a vision and commitment of what we want to achieve, setting some targets, and then we start with the city planning process. And with this process, we achieve a heating and cooling transition strategy. And once we have the strategy, we can move to the execution part and to actually implement the different projects. And after that, we end with the review report and upscale, of course. But going through the specific steps of this workflow, we start with the vision. As I said, this is the first step for decision makers in the municipality to develop a vision and some common objectives on heating and cooling. Then we should create a heating and cooling working group that is officially recognized by the municipality. This working group would have to define some roles and some responsibilities. And it is very important also to identify all the relevant stakeholders in the area so that we can create a stakeholder consultation group for consultation during the whole phase of the plan. Once we have achieved this, we can move on to assessing the current situation of our municipality. And this is just creating an inventory of the energy demand that we have in the municipality, the supply options, the potential that we have in the area for renewable energy or excess heat, wastewater heat could be too. And we have a very useful tool that can help us in this creation of the inventory and potential. This is the Hot Maps tool. This is a GIS-based online software that can support authorities and energy planners to set up a strategic heating and cooling plan. And yeah, this tool gives us so many options for our selected area. We can see what is the demand in like you can see in this map, you can see the hotspot of demand for heating. We can also see the potential that we have around, how much wind we have in the area for wind energy, how much sun we can get. Also the excess heat that we have from the industries around. This is a very useful tool. And with this tool, we can create the zones with similar characteristics in the area that need to be supported. We can also create scenarios for the future, for example, estimating the demand that we will have in 2050, for example, and the increase of this demand, what would need in terms of supply, etc. So for this, the Hot Map tools is really useful. And once we have done this phase, the result will be a heating and cooling transition strategy, a formal plan with in the form of a roadmap with some milestones, goals to achieve. And from this plan, we can pass to defining some specific measures and project proposals to achieve these goals. And these project proposals need to have a check-in on their project feasibility. And for this, we also are promoting the Thermos tool. As I mentioned it before, this is a tool that is very useful for the feasibility assessment of district heating and cooling networks. This web-based software can allow us to analyze different supply points in the city and how this could connect to actual buildings, knowing their heat demand. And yeah, we can create so many different network options instantly. As you can see in this example, we created a supply plant in the right side and selected several buildings in the surroundings, and the tool can tell us what are the options to supply actually these buildings, what are the pipes that we should install, the actual path of the pipes. You can see this maybe a bit better here. This is an example that we developed in ICLEI, creating a new district heating network for the town of Riegel and Kaiserstuhl in Germany. This big orange building is the building that the town told us that could be the supply plant. So we decided to install here a biomass plant with the characteristic that you can see here in the slide. You can change the plant capacity, you can select the capital cost, the annual cost of the plant, which will be the CO2 emissions. So you can, if you decide to put a gas plant, for example, you can also change the emissions per kilowatt hour so that you can adjust the values. And then we run the model selecting 13 different buildings to be supplied. And you can see this is the result. The orange parts would be the actual network, yeah. And the tool will also give us the diameter of the pipes to be installed. It gives us also the emissions, the total emissions per year that we will have. And as you can see in this table over here, the tool also gives us the capital cost of the network, operating cost, operating revenue, and the NPV, which in this case we can see that is profitable. In the bottom right corner would be the profit that we would obtain from this network. So I hope this was interesting, and thank you very much. If you have any questions, you can let me know, and I hand it over back to you again, Rohit.
Thanks a lot, Julen. That was really good stuff. Interesting presentation. I mean, we can open the floor, but before we do that, I have a few questions that I wanted to ask you both. For the first thing that comes to my mind as a non-expert, as you guys can tell me and tell others who are listening to us, what is that indicator or threshold level where a city can decide that they should go ahead for a wastewater heating or cooling network? And also for the city-wide land, or should it be for a certain district? Can individuals also see this for their own buildings, as Nick mentioned so many examples, but just wanting to know what is that element or criteria that can, you know, let's say, start or initiate the process of somebody going ahead with this concept and trying to do pre-feasibility and so on.
My comment to that, Rohit, would be that without people knowing how much heat or cooling is available within the network, it's almost impossible for them to make a judgment. That's I guess the point that I was trying to make is there is a resource there, but people don't know about it. And so unless they know about it, they can't integrate it into planning. They can't even use it in the decision making. So that's really the first step, is to make the data available, make the information available. Let's assume that a city has done the heat mapping, and so the data is then available to the community. Typically, the buildings, and so with wastewater heat recycling, they work by far best when you've got some scale. And so, and one of the main reasons for that is that often there's money needed in terms of infrastructure to get access to the wastewater. So ironically, it's very easy to put wastewater into a pipe. If you want to try and get it back out again, it's not so easy. Sometimes there are easy access points. One of these being the wastewater treatment plant. We saw some examples of that. But there are other easy access points often available within cities, which are called pump stations. And so they are big concrete chambers where it's easy to get to the wastewater. If you're lucky enough to have easy access, then the investment costs are not so high. If you don't have a pump station or a treatment plant nearby, then you do have to invest some money. Basically involves digging a big hole beside the sewer pipe. You put down a concrete chamber, and then you can make a tap in into the sewer pipe. You can get your wastewater, and then you can use it. So often, because you need to make those investments, wastewater heat recycling systems are quite expensive compared to other types of systems. And so to get the best return on that investment, it's best if you can have some scale. And so the sort of opportunities which make really good financial sense often are some of the examples I showed. So things like the swimming pool centres and the hospitals. Why? Because they have long operating hours. They tend to be operating 7 days a week. They're operating for many hours per day. They are using heat all of the time, or pretty much all of the time. And so you're getting a lot of utilization of the energy source. So those sorts of things make very good business cases. The other thing is, if you can dig one or create one infrastructure system and use it to feed multiple buildings, so you get more scale, again, the business case stacks up really well. So generally, we're looking for projects with some scale or high energy needs, long utilization, those sorts of things. Wastewater heat recycling, the sort of things that I'm talking about, it doesn't make sense to try and do it for one house, okay? But if, in the example like we saw in the Netherlands, or I know another one in Sweden, when you're doing thousands of houses, well, then it does make sense.
All right, that's interesting. Julen, you want to add something to it?
No, well, actually the wastewater heat as a new energy supply was quite new to me also. So it's very interesting. I see there's a lot of potential. And given the actual situation in Europe, I also think that any kind of new innovative and renewable or carbon-free source is really valuable and to be considered. These tools, which I presented, can really help into the planning and moving forward. And I think integrating all of these options for a much better and more sustainable heating and cooling future, in not only in Europe, of course, in the world. So very interesting.
That's correct. I mean, we are getting some questions. I mean, people, please send in more questions and comments or remarks you have. Nick, you mentioned about the data that needs to be collected. So you showed also in your presentation that so many wastewater treatment plants around Europe, and I mean, this is true for all countries, all parts of the world. Asking from more of a global South perspective, what is the data that they should start collecting, let's say now, so that they can plan ahead in the future? Because wastewater treatment plants are there. I mean, some are planned, some are not planned with respect to the city planning, but they are existing, and it's only growing as the cities expand and grow, the number of people grow. This is something is not going to stop. The wastewater amounts, perhaps, or the volumes is going to increase. So what kind of data they would need that they start measuring, collecting, so that this can be properly fed into a project planning, etc., for this kind of a network and recovering the energy?
So I think in Asia, Central Asia and Southeast Asia, typically a lot more cooling is needed. than heating. But whether it's heating or cooling, we need thermal energy. And what I would encourage cities to do is to again, it really comes down to the mapping. Once you've got the mapping, then you can see the flows of heat through the city. And so what we can identify once the mapping is done is you can identify kind of like hotspots within the network, where you have 2 or 3 major branches coming together. So that's a junction where there's a lot of capacity available. And so once you start to identify these hotspots within the network, then we can say they would make good locations for an energy center to feed a district heating or a district cooling network. Because with developing parts of the world, often the below ground infrastructure is maybe not fully built yet, or it might be already undersized, because of the urban growth rates that are happening. Intensification by going to multi-level buildings and so on, they can start to overwhelm the capacity of the pipes in the ground. So with developing countries, if the infrastructure is not yet built, or it already needs to be upgraded or so on, then once we can identify these hotspots within the network, we can say, okay, you have to dig the roads up because the pipes are too small, or there are no pipes there at the moment. We have to put pipes in. Let's already put some infrastructure in the ground so that we can use this heat. Maybe we won't use it for 3 years or 5 years, but let's provide the access now. And then we can plan to have a district cooling system, let's say, just right here, because we know there's going to be urban growth in this part of the city, or there's going to be intensification in this part of the city, or maybe there will be some industrial parks constructed here, and we know that they're going to need a lot of heating or cooling. So the access to the energy does not have to be always outside the city at the wastewater treatment plant. It can be right in the city, but without the mapping, you can't often, you need the mapping to pick the best spots. And then from there, you can make your planning for infrastructure, for energy. So for me, it comes down to the mapping. In terms of how much capacity is available, there are things that we have to take into account. There's temperatures, we have to look at the characteristics of the wastewater, look at the flow profiles. Like I say, we have to look at the treatment plant. So there's a number of things that have to be considered so that you don't overcool or overheat the wastewater. But the first step really is the mapping. That gives you such a base that you can then make a lot of decisions from.
Yeah, no, absolutely. And you mentioned a lot about mapping, and Julen also talked about the process and the methodology that they are following for the projects that they have in Europe. So I believe this is really useful for the attendees, the policymakers who are present here and listening. Let's pick up some questions from the participants. One that came was more attending towards the fact that you mentioned that this is still an invisible energy source, and perhaps my question would be how we can make this more visible from the city's perspective, from the municipality's perspective. And the question is more targeted towards that. What is standing in the way? Is it the costs for maintenance, or is it the reduced lifetime of wastewater? Is it the equipment installation cost, etc., that is being targeted? And the second part of the question that they are saying is that talking about wastewater in district heating networks, and that what you mentioned, that using this in individual houses might not make sense, but would it make sense by using an air source heat pump? So there are two different levels of questions.
Yeah. So what's standing in the way? From my experience, very often the biggest barrier is just a lack of awareness. People, they just don't think about it. They don't know about it because fundamentally, I've spent many years bridging, if you like, these sectors between the building sector and the wastewater sector, or the public sector and the private sector. The wastewater utilities in almost every city, they get the heat given to them, or they have this resource available, heating or cooling, but they don't use it. They have no use for it. And so for them, they don't particularly care. And on the other side, we have the buildings sector who have a need for heating and cooling, but they don't think about the wastewater pipes because they don't know how the network looks. They don't know how much capacity could be available to them because the data's never been created. So the biggest barrier is firstly lack of awareness. And sometimes there are bureaucratic type barriers. I've worked in many cities where the local regulations, which were maybe written, 20 years ago, 30 years ago, 40 years ago, in a time when we weren't so focused on climate change and we didn't have these energy crises like we have right now. When those policies were written around wastewater, nobody wanted to take the water out of the pipe. There was regulations written about putting wastewater down, and that was as far as it went. And actually there sometimes are rules written that you are not allowed to take water out of the pipe. So sometimes we come across these sort of bureaucratic type barriers where we have to go and engage with the local authorities and say, look, the rules need to be changed because you have this energy resource that we all realize is immensely useful now, but there's a rule that was written 30 years ago that actually means it's illegal for people to use it. So that's sometimes there's work needed in those areas just to update some of these regulations to allow access to use this energy. So that can be also a hurdle. A third barrier can be cost, because if there's infrastructure works needed, infrastructure works are typically not cheap. And when people are making decisions based purely on capital cost, what will they be comparing to? One will be wastewater, the other one is likely to be an air source system because air is easily accessible. But as I sort of explained in my presentation, with more and more air source systems coming in, there are some other issues that start to creep into cities with noise pollution, with urban heat island, and air source systems are typically not as efficient. And so as there's more and more electrification of many different things, not only heat, but transportation and in some cases agricultural and things like that, as there's more competition for electricity, then having systems which are not so efficient in using electricity becomes more problematic. So if we only look at the capital cost, yes, sometimes wastewater heat recycling systems are more expensive. But the example I gave from Washington, DC, where they looked at a conventional system, they looked at their wastewater system and they said, well, you know what, the wastewater system was 20% more expensive than the conventional one, but over time, that's a good investment. So, you can only make those decisions on a project by project basis. But in general, if we can minimize the infrastructure needs, cost needed by firstly planning ahead and making access available, if you can get some scale involved, and if you can get long utilization, all of those things help to actually build a really good business case.
Mm-hmm. And perhaps what you mentioned, what I picked, is the raising of awareness and spreading the message, making it more visible, is something that global networks like ICLEI can work with experts like you around the world and start seeing that this is taken more seriously into various climate and energy plannings for cities and various local governments. Two more questions. Let me pick up one first for you, Nick. Now that we're talking about technology, somebody has mentioned about water heating, heat recycling systems. So in this, is there a particular type of system that is more preferred? And the second question then for you, Julen, from the projects that you have been, working in Europe, do you see, or how feasible do you see renewable energy technologies for district heating, where housing stock, or like for old buildings, whether you are either refurbishing it or perhaps just to cater to the current building that is there, which is old? So first, maybe Nick, go ahead, please. Yeah.
So there was a question about the technology. So there are a number of technology suppliers who make the special equipment needed to use wastewater for heating and cooling. And that's one thing that is important to understand. You can't just use normal heat exchangers, because if you put wastewater through them, they block up. So you do need some equipment which is designed for that purpose. There are a number of technology suppliers in the market now, and many of them have been doing this for quite some years. And so that's where I said the technology is becoming mature now. What is the best choice of technology for a particular project is made on a project by project basis, because some technology is more suited to smaller projects. Other technology is better suited to projects with a real scale. You can only make those decisions when you're really starting to get into the design phase of the system. Fundamentally, they all kind of work the same way. So if we want to talk about, and I promise not to get into the technology, but I'll do a 2-minute introduction to it. If you want to take heat or use wastewater as a thermal source, heating or cooling, the heat exchangers basically fall into 2 broad groups. You either have heat exchangers which are installed down into the sewer pipes and the water flows over them, or you have heat exchangers which are outside of the pipes. And so you take the wastewater, bring it out, pass it through the heat exchanger, and the wastewater goes back into the sewer pipe. So those are the 2 broad groups of technology. So which one is the most suitable for a particular project? It's a project-based decision. I couldn't say this one is always the best, because that's not the case. They typically have advantages and disadvantages. There's installation requirements, there's physical footprint needs. So there's a saying in English, it's horses for courses. You can only make those decisions when you are talking about a specific project.
Yeah, thanks, Nick. Julen, please. Also, we are completely out of time, so as crisp and short, please.
Okay. So very quickly then about installing new district heating networks in cities with a very old building stock. Well, I would say that this is 2 different topics. On the one hand, the refurbishment of old buildings is very recommendable, of course, so that we can increase the energy efficiency of the buildings. We don't need so much energy, and therefore if we use less energy, we will emit less, obviously. And on the other hand, we have the district heating as a system for supplying buildings with hot energy, whether they are old or new buildings. I would say that district heating is still the most efficient way for thermal energy, rather than using individual boilers, because district heating can allow us use some excess heat that we can have in the city and then distribute it in the city is really efficient, especially for highly dense areas, which is the case of most cities. And I would say it's a good option independently. If we have an old building stock, we can have the cases of Northern or Eastern Europe where there's very old cities with old buildings, but they all have district heating systems in place. So I think both things are very important, refurbishment and district heating.
Yeah, that's correct. And thanks a lot. And also all these resources that you mentioned, Julen, the tools, etc. I believe this is all available on the various project website as well as on ICLEI Europe website, which people can, of course, freely access and see how that works. I see we are completely over time, and it's amazing that this conversation is so interesting, and we see the participants are hanging on with us. I mean, even though we can go on discussing various questions, there are so many that I have, and now I feel that I have to come back to you later. And this I have to request also the participants who have sent many questions now that are still pending. So we will answer this back to you through our experts after we end the webinar for sure. And of course, I mean, just to close it, we definitely have realized that this is an important source where there is definitely no concern or question about fuel security. This is something that is completely in the hands of the city authority, local authority, and so on, and they can use it to replace the fossil fuels or oil, gas, whatever they are using, and completely be more reliant on this to address their heating and cooling demands, which is cooling, as Nick, you mentioned, is increasing rapidly. I can only say for attaining net zero emissions, for climate neutrality and overarching goals of sustainable energy transition, this is an important mix in all the solutions that we have, and this is something that we cannot miss out on. I can only say that global networks like ICLEI will work strongly with the experts that we have around, working in various projects, and try to see how this can be adapted in various parts of the world, in global north as well as global south cities and regions. We'll share our experiences through various peer exchanges, webinars like these, and many other knowledge products and case studies that we keep coming out and publishing on our website. So with that, I would like to thank our experts here, Nick and Julen. Thank you very much for your time. Also, all the participants who came and joined us and stayed long, also 10 minutes over now. Thank you very much. I hope we have learned a lot today. I learned a lot about this new source and technologies that can be used. I wish you a great day ahead, wherever you are. Good evening and a good day to you. And hopefully we meet again in a next technical webinar and continue our interesting discussions. Thank you very much. Bye-bye.
Bye, guys.
Thank you. Have a good day. Thank you.